Hey there, wake up. Hey, so check this out. This is the Delta 22590 planer, and I don't like it. I didn't buy it from eBay, and I didn't pay that much for it, fortunately. Otherwise, I'd be more riled than I am. Why, pray tell, are you riled up? So, 13 inches in width here. Okay, you would assume there's some precision involved in the manufacture of this. I'm planing oak boards, about 5/8 of an inch thick, and I noticed something odd. I was trying to utilize the full knife area, as not just to wear out one area. The boards on this side were thicker than the boards on this side. Okay, well, maybe it was me. I checked it with a micrometer. Actually, digital caliper. I'm not that anal retentive. Did I say caliper? Anyway, I digressed. So, check this out. Pretty simple, right? You turn the crank handle. Turn the crank. Goes up, goes down. It's all right here. Very clear to see. If you can read upside down, that's even a better thing. And one revolution is a 1/16 of an inch. Wow, how do you know that? Well, it says on the dial here, for one thing, and then with the handy thread gauge, there you are. I don't know if you can read that. Anyway, 16 threads per inch. There you go. In like Flynn. Okay, that verifies the pitch, which correlates with this. So I assume the screw manufacturing is good, meaning on both sides of this device, here and over here. As you crank the handle, it elevates and would go to the correct position. I don't know why it doesn't, and I haven't investigated far enough to see that during manufacture if one of these screws is off. Let's see, we're off about 20 thousandths. So that would be roughly a little more than a quarter of a pitch of the position here. Is that a big deal? Well, to me it is. Maybe there's something wrong with me. No, you don't know me, so feel free to speak up. Anyway, what I did here, you can see in here, these metal blocks, obviously don't belong inside of a planer. They're precision 1, 2, 3 blocks, which I made, and I have a set of 4 matching ones. I'm a tool and die maker and engineer. Yeah, I'm one of those weird freaks. Anyway, I put these in here as a gauge block, and I raised it up, so obviously it's much thicker than the boards I was machining. The blade is touching on the right side here, just a wisp, just a thickness of paper, about 3.5 thousandths. Over here on the left side, we have about 20 thousandths roughly, and that's in that position. Actually, it's tapered. If I moved it out more, we probably would acquire another 3 or 4 thousandths of an inch. Are you yelling at me now? Hey, don't break your phone. Don't break your phone on my account. Well, here's what my thinking is. I make a face frame for a cabinet, and I put the 2 boards together, and if one is 20 thousandths thicker than the other one, you're going to notice it, right? I will notice it. If anybody was to be a consumer of something made by this, and they had attention to detail, they would notice it. And people appreciate things that are made correctly, right? So, tell me, am I crazy? Is this a bigger deal than I'm making out of it? I don't know. Have you experienced this? Do you have one of these? If you did have the problem and you fixed it, did you go in and adjust one of the screws just a fraction of a skosh? It's something I'm looking at doing. Sometimes you leave well enough alone too. There's always that. One other thing we're going to be doing, I need to sharpen the blades. That's the other thing that kind of pissed me off, is the blades are pretty rough, and the only thing I have run through them is a few there may be 20 pieces of oak board, no nails, and I ran pine through it. I made a laminated railing for a deck and pergola I made earlier this year. Pine's pretty soft wood, and it was all nail free, and I'm a little disappointed also in the quality of the blade. I understand these are disposable blades, but what I've ran through it so far and the 2 times I've used it, again, and I wasn't hogging at all. We have the thickness gauge here, right? You see how your board contacts this, and it gives you a heads up. Like, hey, buddy, you're going to kill this thing, and you'll have to reset it, right? Okay. So I never even came close to 30-second per pass because I don't want to kill the motor. You know, you can overload it. I mean, looks like we got the red line here at 3:30 seconds. Boy, mama, that's maxing it out. I'm pretty sure it would stall. And I said this was 16 threads per inch. And let's see if we can pick that up here. So we got the screw pitch gauge, and it falls right inside. You see that? This is handy to have. They're actually not that expensive. I would recommend getting one if you're a handy person, you like to do stuff around your place, keep things nice and neat, know what you're buying when you go to the hardware store, help your buddies out. Another thing I want to bring up about this. So it's a portable planer. We've got handles. That's good. The fit and finish of this is nice. I like the blue. The silver is terrific, right? This polished stainless steel, very nice. Now, out of the box, they said that the infeed and the outfeed table were tuned in, dialed in, right? I was getting taper, and I thought, well, I'm an amateur woodworker, and I thought, okay, well, what are you doing wrong, dummy? I made sure I had the mechanism locked, so I wasn't screwing up there. That was okay. So they recommend to check the elevation of the infeed, outfeed in relationship to the precision platen surface here, to put a dime on each side of the infeed, outfeed, and dimes here. The reason they recommend dimes is because it's uniform thickness, and then you place a straight edge on there, and the gap should be uniform, which is fine. I used washers. I measured. They were the same thickness. I didn't have any coins. Well, I actually had 2 dimes. But the crazy thing is, to me it's crazy, the way you adjust the elevation, I was assuming there would be a mechanism on the side here maybe, or something through here where I could tweak it and I could look at the gap as I was adjusting it. To me, I would think that would be consumer friendly. But no. Again, maybe it's just me. I mean, maybe I just got something wrong with me. One thing I did notice, we have these screws here, and these are the adjustment screws. And you have the lock nut, and you have the hex bolt. This is the surface you use to adjust it, and you have to lift it up and down, adjust it a teeny bit, make sure they're both the same elevation, left and right. You adjust it, put it back down, put your spacers back in, on the infeed and outfeed side, mind you, and then check the gap. That's just kind of tedious. Folks from Delta, I'm sure they got great engineers, I'm sure. But it seems like it would be a whole lot easier if we could have something right here we could tip this up and down slightly, get it dialed in, and it would really be awesome. Especially if you shipped it from the factory with the planer head parallel with the platen and the in-feed and out-feed adjusted. Maybe I got a Monday morning hangover assembly. Yeah, I hope not. Anyway, let's move forward. Not for me yammering. I want to take those dull blades out, and what I want to do is see if I can touch them up a little bit, and let's make a fixture where we can actually do this ourselves. That's the plan. Let's see what happens. So we're still working on this 13-inch Delta 3 knife, cutter head planer. Real quick on the knife removal to refresh. Maybe you buy a set off Amazon or from your local big box store. The instructions say crank it up to the 4-inch mark with the adjustment screw here. Come around to the outfit side. Here you have the dust snorkel. Removing that, it releases this Secret Service button, which actually latches the cylinder knife holder in place to facilitate the removal, which is a good safety device. You press it down and you can rotate it. Looking at the knives, I'm sure you can't see it here, it's just a GoPro camera. Anyway, they're pretty chowed, and very curious about what's going on here. Sorry, in this area of the cutter head. But I'll get them out of there. It's pretty straightforward. Came with this awesome Delta tool, and we'll get in here. We'll get this into position. It'll latch like that. Goes into a detent. Get these out of here, and let's pick up with removing the knife and looking at it, and then start talking about how we're going to sharpen this. What I want to do here is the same thing you might be able to do with your 6-inch, 8-inch jointer knives, just to give them a quick touch-up while you're waiting for the new set, or maybe you're not interested in buying a new set because you don't need to. All right, let's get into the third act. All right, let's see how the knife removal is going on. Hey, first things first, folks. Always make sure it's unplugged. I do this when I change the blades on the table saw. If you don't have a plug with your table saw and it's 220 and wired into the wall, go shut the circuit breaker off. Things happen. Funny things. They don't turn out funny. Odd things that don't turn out funny. Anyway, make sure your equipment's unplugged and powered off before you work on it. Nice thing is, removing these 7 screws here with this Delta provided Torx driver. Remove the hold down bar from here. Get that out of there. We have our blade sitting here. Now, notice the blade is indexed. Has a little slop, let's say maybe almost a 1/16 left to right. And I would say it has, front to back, maybe 10 thousandths. Excuse me, 5 thousandths. Get the blade out of there. Be careful if you want to wear gloves. That's not a bad idea either. So I want to make a sharpening jig for this. The sweet thing is, the good folks at Delta provided a double-edged blade. Again, I'm new to woodworking. If you know this, you're like, hey, dummy, everybody knows there's a tube cutting edges. And good for you. Now I can act like that. Anyway, I wanted to check the angle because what we're going to do is use the table saw, and this is the plan anyway, cut a groove that's awfully thin, and see if I can drop this in the groove in a piece of material and sharpen it. Now, I did use the handy dandy protractor here to discover the blade angle, knife angle, is actually 40 degrees. I was assuming it was 45. I double checked it too. Actually, I started off with this little adjustable square, just doing a quick cursory check. Oh yeah, it's 45 degrees. No, it wasn't. So let's see if we can make some kind of a fixture and sharpen the knife edge with a stone. Okay, coming up, knife sharpening jig. Hi there. Hey, let's wrap things up. The fixture for sharpening the planer knives has to be in a second video. It's got to be 2 parts. Otherwise, it's just going to be too long, and I don't want to bore people to death. If you want some information, hopefully you can find something here useful. So we get the microscope set up, and I've got a penny there just for reference. Let me get the camera set here, and let's take a look at this blade. There's 3 blades. A couple things I found interesting. The wear was pretty uniform for all 3 blades, which is to be expected. I put a little Sharpie red mark here. This is the brand new edge of one of the blades. Come on. And here, I'll get this one out of here. Okay. Thank you for bearing with me. If you see right here, focus, these aren't laboratory conditions. I'm kidding, this is just a microscope I have in my shop. Anyway, this is the brand new edge. And there's 2 locations on this one blade I marked out that are already kind of chipped out from either the manufacturing or the handling process. And obviously, if you're going to have that as a primary cutting edge to start with, you kind of have a disadvantage to begin with. Take a quick look at the wear we experienced, and it's pretty uniform. You see there's like a, here we go, factory edge, not used. Remember, this is a 2-edged blade. We get a free edge, mercy edge, and this is the edge that's been used. And you can see there's this bit of a deposit of tannins or some pitch or something from the wood, and then you can see wear. And trust me, that wear is significant enough. There's a nice chunk taken out. The wear is significant enough that it actually makes things difficult to get a good finish, and you do notice it in the performance. So I think we're going to touch up both edges of the blade in the next video. All right. Hey, thanks for watching, and we'll see you in the next video.